Everyone, welcome back to 10th standard maths class. In the previous video we have learned about square pyramid. Now in this video we are going to learn about a new shape, that is cone. You all are familiar with this shape. Okay, cone. This is the shape of a cone. Okay, this is also a pyramid because there is an upper vertex and base is a circle. Okay, for a normal pyramid we know base must be what? A polygon, but here it is a circle, but this is also a pyramid with circular base. Okay, so this is the shape of cone. Now let's learn the features of the cone. Okay, so as I told you, the base of the cone is a circle. Okay, circular portion is there, so this is base. Now for a circle we know a center will be there. Okay, a center portion is there. As it is open here we can't mark the center. Okay, but if it is a closed shape, a conical firework, that is an example for that. Okay, conical firework, in that shape this portion is closed, so we can mark the center point, and from that center point to any point on the circle we can mark the portion as radius. Okay, now this is the apex point, and from this apex point if we mark a perpendicular height to the exact center point, from this apex if we mark a perpendicular distance, that is the height of this cone. Okay, that is the height of this cone. Now same like the square pyramid, we have a slanting line also there. Okay, from this apex to any point on this circle a slanting line will be there. Okay, that is known as slant height of the cone. Okay, now let's draw the figure. This is a representation of a cone. Okay, so here this is the center point, this is the center, and this line from the center to any point on the circle, that is known as radius. Okay, small letter r. Radius of cone is denoted by small letter r. Now from this apex to the center perpendicular line, that is the height of the cone, denoted by small letter h. Okay, from this apex to the center, that is height. Now this portion, okay, this is known as slant height, and that is denoted by small letter L. So these three are the major parts of the cone: slant height, height, and radius. Base is a curved portion. Okay, now when you open this cone, we will get a sector. What do you mean by sector? Sector means it's a part of circle. In 9th standard you have learned about this. Okay, this is a sector. Okay, this portion is known as sector, that means a part of the circle. Okay, a circle we can divide into so many parts. Okay, through the diameter we can divide the circle into so many parts, and that part is known as the sector. Okay, one portion, that is known as sector. In that sector a central angle will be there. Okay, so this is the central angle that we can mark as x degree. Okay, so in this sector this is the central angle portion, and this is what? A part of the circle. Okay, a part of the circle, that means an arc. Okay, an arc length. Now these two portions, okay, this line and this line, what is the speciality of these two lines? When we place this sector here, what happens? These two becomes what? Radius of the circle. Okay, these two parts are radius of the circle, that means this is radius, and radius already there in cone, that we denoted by small letter r, that is radius of cone. Now radius of sector, okay, this is radius of sector, and that we can mark as capital letter R. Okay, capital letter R. Radius of sector denoted by capital letter R. Don't confuse, small letter r is for radius of cone. Now when we join this sector, okay, when you join this sector we will get cone like this. Okay, we will get a cone like this. This is a small sector, that's why. So by bending a sector we are making a cone. Okay, now after making a cone, what will happen to this radius? What will happen to this radius of the sector? Okay, after joining this radius portion becomes what? Slant height of the cone. Okay, already this curved portion is the slant height of cone. That means the radius of sector portion, This is the radius of sector portion. This capital letter R becomes slant height of the cone. Okay, when we make a cone by using this, we can see that capital letter R will be same as slant height of the cone. This is slant height. Okay, that means the speciality of sector and cone is capital letter R is same as L. Okay, this is a speciality relation between cone and sector. R equal to L. This is useful in problems. Okay, so keep remember radius, capital letter radius is the same as the slant height of cone. Now one more equation we have learned in 9th standard for the sector, that is x is equal to central angle, x is equal to 360 into R by L. Okay, this is the equation we have learned in 9th standard. This also we need in this chapter. Central angle equal to 360 into R by L. R means radius of cone. L means slant height of cone. Sometimes instead of slant height, radius of sector will give. At that case also what we can write can be R by capital letter R. That also possible. Okay, so general equation is 360 into R by L is x. Now let's learn equations for cone. Okay, first one is base perimeter of cone. Base perimeter. What is the base of cone? We know base of cone is a circle. Okay, base of cone is a circle. Therefore, base perimeter means circle's perimeter. What is the equation circle's perimeter? Yes, circle's perimeter is 2 pi r. Okay, perimeter of circle is 2 pi r. Therefore, cone's base perimeter is also 2 pi r. Next is base area. Okay, perimeter over. Next is base area. All this for cone. Okay, base area of cone. So as the base is a circle, we can write area of circle as base area of this cone, because for a cone its base is a circle. So area of circle is enough. That equation is pi r square. Okay, pi r square is the equation. Next is curved surface area. Okay, CSA of cone, curved surface area. So curved surface area means that portion is around this portion. Okay, not the base, this portion, around this portion, that is curved surface area. That equation is pi r L. Okay, pi r L. In this chapter you have to learn so many equations. So connect each and every equation so that you can remember all the equation. For the square pyramid, what was the equation CSA of square pyramid? It was 2AL. Okay, 2AL was the equation. For a square pyramid, base is there. That means base at A slant height and 2 is also there. But for cone, here one circle. Okay, one circle is there. For a circle, pi is must. Okay, that's why instead of 2 pi comes, no base edge for cone, only radius is there. That's why instead of A, R comes. And L is the same. Okay, compare and learn. So here CSA of cone is pi r L. Okay, curved surface area pi r L. Next is total surface area. Okay, TSA. Total surface area means only two surfaces there for cone. One base surface, that is the circle portion, then one curved surface portion. So base portion area we already got pi r square. Next curved surface area is pi r L. Okay. Now here we can simplify this equation. Pi and r common here, so that we can take outside. So pi r. What remains here? From pi r square we took pi r. So remaining is r. Plus from pi r we took pi r outside. So the remaining is L. So pi r into r plus L is the total surface area of a cone. Okay. So these are the important equation you have to keep in mind. And one more is there, same like the square pyramid. Here one right triangle, that is LHR. This is a right triangle. And here L is the hypotenuse portion, H is the altitude, radius is the base portion. By using the Pythagoras theorem, we can find L, H and R. Okay. So that's all about cone and sector. You have to learn all these equation and thorough with this concept. Okay. Now let's do the problems.
Page number 198, first question. What are the radius of the base and slant height of a cone made by rolling up a sector of central angle 60 degree cut out from a circle of radius 10 centimeter?
Here in this question we have to find the base radius and slant height of a cone. Okay, base radius and slant height of cone. And what are the given measurements? Formed by bending a sector with radius 10 centimeter. Okay, radius 10 centimeter. That means that radius is what? Sector with radius. Sector with radius means that is radius of sector. Okay, radius of sector is given, and radius of sector we are denoted by what? Capital letter R. That is radius of sector, and that is given as 10 centimeter. Radius of sector is given as 10 centimeter, and one more is given, central angle. Central angle also given, that is 60 degree, and central angle is denoted by x degree. So x degree equal to 60 degree. These two are the measurements given in the question. From this we have to find base radius and slant height of cone. So base radius means what? Small letter r. Radius of cone is small letter r, and slant height, that is L. R and L we need to find here. So here we already know what one concept we learn, that is capital letter R is same as small letter L. R equal to L. So if you want to find L, what we can write here? It is same as 10 centimeter, because capital letter R is given as 10 centimeter. Therefore, slant height is also 10 centimeter. Okay, now we have to find small letter r, and central angle is given. So let's apply central angle equation, that is x is equal to 360 into r by L. This is the equation. Okay, now here in this equation x already given, that is 60. 60 equal to 360 into r we don't know, that is what we need to find. So keep it like that, r by L. L we know what? 10. Okay, r by 10. Now 0 0 we can cancel. Now to find r, keep r there and take 36 to this side, that is 60 by 36. Okay, now we can simplify this. Both are multiples of 6. In 60 how many 6? 10 6 are there. In 36 how many 6? 6 6 are there. So 10 by 6. When you divide this, you will get the answer as 1.66 centimeter. Okay, so 1.66 centimeter is the base radius of cone. Okay, base radius of cone. Radius of sector already given. Okay, so this is first one's answer.
Next question number 2. What is the central angle of the sector to be used to make a cone of base radius 10 centimeter and slant height 25 centimeter?
In this question we have to find the central angle. Okay, central angle of a cone which is used to make a circular pyramid. Circular pyramid is the same as cone. Okay, so central angle of sector we need to find. Base radius and slant height of cone is directly given. Okay, so base radius of cone. Base radius of cone is denoted by small letter r. Okay, all the notations you have to learn. Base radius of cone small letter r, that is given as 10 centimeter. Next is given slant height, that is small letter L. Slant height is given as 25 centimeter. It's a direct question. Now how we will find central angle? What is the equation? X is equal to 360 into r by L. This is the equation. Just apply in this equation. That is 360 into r we know, that is 10 by L, that is 25. Okay, now we have to divide this. Now here in 25 5 fives are there. Now in 36 7 fives are there. One balance, that is 10. Now in 10 how many fives? 2 fives are there. So 72 into 2. Here also we can divide. In 5 only 1 5, in 10 2 5. So 72 into 2, 144 degree. Okay, so 144 degree is the central angle of that particular sector. Okay, so this is second one's answer.
Next question number 3. What is the ratio of the base radius and slant height of a cone made by rolling up a semicircle?
Here in this question we have to find the ratio between radius and slant height of a cone. Radius and slant height of cone means ratio. So ratio is denoted by is to. So radius and slant height. Ratio between radius and slant height means R is to L we need to find. And that cone is made by what? Bending a semicircle. Okay, sector means here this cone is made by using a semicircle. Okay, that is the only clue given. Semicircle, that is the only clue given. Now we know semicircle means what will be the central angle. Semicircle means the central angle will be 180 degree. Okay, now in order to find the ratio between radius and slant height, let's use the same equation. X is equal to central angle, because only central angle we have, that's why we are going to apply central angle equation. So X is equal to 360 into R by L. Okay, now here X degree means central angle. Central angle is what here? 180 degree. Okay, so 180 equal to 360 into R by L. Now keep R by L here and take this 360 to this side. That means 180 divided by 360 equal to R by L. Like this we will get. Now here 0, 0 cancel. 18 and 36 are multiples. In 18 only 1 8. In 36 2 8s are there. Okay, that means 1 by 2 equal to R by L. Now in 8th standard we have learned that x by y. This we can write as a fraction like x is to y. Okay, same like here 1 by 2. That means it is 1 is to 2 equal to R by L. R by L means R is to L. So what we got as answer? R is to L. That ratio between base radius and L is 1 is to 2. That means if radius is 2 centimeter, suppose if radius is 2 centimeter, its slant height will be what? Double. 2 2s are 4. 2 is to 4 will be. Okay, that means whatever be the radius, its double will be slant height when if it is a semicircle, if sector is a semicircle. Okay, so this is a ratio 1 is to 2. So this is a third question. Our next subheading is curved surface area. Okay, curved surface area we already discussed about the equation. What is the equation? Curved surface area of a cone is pi r L. This is the equation. Okay, no more explanations to give, just equation pi r L. Now let's do the problems. Page number 199. First question. It is a direct question. Question is, find the curved surface area of a cone with the base radius 12 centimeter and slant height 25 centimeter. Okay, base radius of cone. Base radius of cone means small letter r. R is given as 12 centimeter and slant height. Slant height is given as 25 centimeter. Find the curved surface area. Direct question. Okay, so curved surface area means CSA, that equation is pi r L. Just apply the values. That is equal to pi into radius is 12 into L is 25. So 12 into 25. Answer is 300 pi centimeter square. No need to apply the value of pi. Okay, if it is specified only you can apply, otherwise no need to apply. So 300 pi centimeter square is the curved surface area of a cone with the base radius 12 centimeter and slant height as 25 centimeter. Okay, so this is first one's answer. Next is question number 2, that is find the surface area of a cone with the base diameter 30 centimeter and height as 40 centimeter. If question is like just to find the surface area, it is mean by total surface area. Okay, if curved surface area, they will specify like curved surface area. If just surface area means it is total surface area. Okay, so total surface area of a cone with the base diameter 30 centimeter and height 40 centimeter. That is we need to find here. Okay, so what is the equation? TSA, total surface area equation is pi r into r plus L. That let's apply later. Here L is missing. Okay, L is not given. Instead of that, H is given, and radius is not directly given. Diameter is given. Okay, if diameter is given, we can easily find radius by what? 30 by 2. That is 15 centimeter. Okay, so radius will be 15 centimeter. 30 is half. Now we need to find L. Okay, in order to find L, what is the equation? I told you one right triangle is there for a cone. This is L, this is H, this is R. Okay, for a cone. So L is the hypotenuse portion. That is L equal to root of H square plus R square. That is equal to root of H is what? 40. So 40 square plus radius is 15. 15 square. That is equal to root of 40 square is 1600. Okay. Plus 15 square is 225. Now when you add this, you will get 1825. For this, no root value. When you factorize this, you will get like this: 1825. We can take 5. In 18, how many 5? 3 5s are there. Balance is 3 here. 5 3s are 15. Balance is 3. Write 3 in front of 2. So 32. In 32, how many 5s? 6 5s are there. That is 30. Balance is 2. So 25. In 25, 5. Next again with 5. In 36, 7 5s are there. 7 5s are 35. So balance is 1. That is 15. In 15, 3 5s. Now we can pairing. So here 5 root 73. So slant height will be 5 root 73 centimeter. Okay, so this is slant height. Next we have to find the total surface area. So TSA equation is pi r into r plus L. So here radius is what? 15. So here we can write it as 15 pi inside the bracket 15 plus slant height is what? 5 root 73. Okay, this much is enough. 15 pi into 15 plus 5 root 73 centimeter square. This is the TSA of this particular cone. Okay, no more simplification, just apply the values. If question is like to find the total cost or correct to centimeter or correct to millimeter, like that you have to apply the pi value. Okay, otherwise no need. So this is the answer for second question.
Next question number 3. A conical firework is of base diameter 10 cm and height 12 cm. 10,000 such fireworks are to be wrapped in color paper. The price of the color paper is 2 rupees per square meter. What is the total cost?
In this question, they have mentioned that it's a conical firework. Okay, conical firework means it's a shape of cone. Okay, what we need to find here? Total cost to cover that cone. Okay, total cost to cover that cone means if covering, like the question, if it is covering or painting like that, we need to find the total surface area. Okay, they won't specify that. If it is to cover the portion or to paint, like that, question is total surface area. Okay, so here we have to find the total surface area, that cost, total cost at 2 rupees per meter square. Okay, 2 rupees is a cost for 1 meter square. So first of all, we have to find total surface area. Total surface area of first one firework, then 10,000 firework. Okay, so here what are the measurements given? Diameter is given. Okay, D equal to 10 centimeter is given. So from this radius will be what? 5 centimeter. Okay, next is given as height, H equal to 12 centimeter. Okay, H equal to 12 centimeter is given. Now in order to find the total surface area, we need L also. So equation is what? L equal to root of H square plus R square. So H square means 12 square plus 5 square. That is root of 144 plus 25. That is equal to root of 169. That is 13 centimeter. Okay, 13 centimeter is L. Next we have to find TSA. Okay, total surface area of 10,000 firework we need to find, but first find one firework. TSA of one conical firework. So equation is pi r into r plus L. Pi r into r plus L. So here pi we need to apply because total cost we need to find. Okay. So here first of all let's write pi as pi itself. Then radius. Radius is 5 centimeters. So pi into 5. Then again radius. So 5 plus slant height. Slant height is 30. Okay. So that is equal to pi into 5 into 13 plus 5, that is 18. So 18 into 5 into pi. Okay. So that is equal to 90 into 3.14. 18 into 5 is 90. So 90 pi means 90 into 3.14 centimeter square. No need to simplify now. Centimeter square. Okay. So this is TSA of one conical firework. TSA of one conical firework. Now we have to find TSA of what? 10,000 conical firework. Okay, 10,000 conical firework. If this is for 1, for 10,000 what will be the answer? Here the answer will be 90 into 3.14 is 282.6. When you multiply this you will get the answer as 282.6. That answer into 10,000. Okay, this is for one firework. This is when you multiply this with 10,000 you will get 10,000 fireworks TSA. This is in centimeter square. We want to find the answer in what? Meter square, because the question is 2 rupees per meter square. Okay, so if it is in centimeter square we have to convert the answer into meter square. So how we will convert this into meter square? Just divided by 100 into 100. Okay, into meter only divided by 100. Meter square means 100 into 100. So from this, these two zeros cancel. These two zero cancel. That means TSA of 10,000 conical fire is 282.6 meter square. Okay, so total surface area is 282.6 meter square. Now we have to find the total cost at 2 rupees per meter square. Total cost to cover this 10,000 conical fire at 2 rupees per meter square. So cost will be what? In order to find the cost, just multiply this total surface area 282.6 into 2. Okay, this is enough. That answer is 565.2 rupees, not meter square, amount. Okay, 565 rupees. Round of 565 rupees is the total cost to cover 10,000 conical fire using color paper. Okay, using color paper we need 565 rupees to cover 10,000 conical fire with the diameter 10 centimeter and height as 12 centimeter. So this is third one's answer.
Last question, question number 4. Prove that for a cone made by rolling up a semicircle, the area of the curved surface is twice the base area.
Here in this question we have to prove that if cone is made by bending a sector as a semicircle, then curved surface area, okay, CSA is equal to 2 times base area, 2 into base area. This is what we need to prove. Curved surface area of cone will be double of base area. This is what we need to prove. Now here, if sector is a semicircle, in the previous section we have learned one ratio. Okay, ratio between radius and slant height. R is to L equal to 1 is to 2. Okay, in the previous activity we have learned this. R is to L equal to 1 is to 2. From this we can write what? R by L is equal to 1 by 2. Okay, if it is so, we can write L equal to what? Take L to this side, 2 to this side. So L equal to 2 into R. Slant height is double of radius. We will get this. We can apply this here. What is the equation? What we need to prove? CSA we need to prove. So let's start from CSA. What is the equation CSA of cone? CSA of cone is pi r L. This is the equation. Now here pi r, instead of L we can write as 2r because it is a semicircle. So L is the same as what, 2r. Now take this 2 in front, 2 pi r into r square. Okay, so 2 pi r square we got. Take 2 here. What is pi r square? Which equation? Pi r square is the equation of base area of cone. That is 2 into base area. So we got CSA equal to 2 into base area. Okay, for a semicircle, r is to L equal to 1 is to 2. From that, slant height is same as 2 into radius. Just apply that in equation of CSA. We will get CSA equal to 2 into base area. So this is fourth one's answer. So this section also over. Hope you understand. Thank you. See you in the next video with the next section.